Yo, welcome back to the channel. It's your boy Street Coder Nate. My bad, 1 second. Welcome back to the channel. It's your boy Street Coder Nate. Today we are going to talk about bada boom, bada bang functions. We are going to learn how to write commands that we can package up inside of procedures and give a name to. So this procedure can, in a way, be our data, right? Like just how a number is a data and string is a data, we can think of a procedure. We can think of a list of commands as a procedure, package that up as data, and then give a reference to that data, and that's called a function. So the reference would be the name for that list of procedures, and whenever we call on that name, that list of procedures would be ran. Right? Cool. So that's what we're about to learn today in this video. So functions. And so you think of functions just as you can think of them in math, mathematical functions. Mathematical functions, f of x, let's take an example. F of x equals, let's say, x squared plus 1, right? So f of x equals x squared plus 1. And so basically this is saying that for all values of y, for all values of y, for all values of x, my bad, there is an output value for y, right? Cool. So x is our input and y is our output. And in between the input and output, there's a processing step. And the processing typically happens on the input, and then the output step is typically what was processed, right? Cool. So in computer science, this is the exact same way. And so our function syntax, instead of saying f of x, we say function. And just as it has its parentheses here, we have parentheses as well. And x, once again, is input. And in this case, they only have one input, which is x. But in multivariable calculus, you can have multiple inputs. And let's say z squared, right? And so here we can also have multiple inputs. We go x, and they're also separated by commas like that. And then we have, instead of this equal sign, we have curly bracket opening and closing curly bracket, which says equal in a way. And then we can say return, which is saying, here's your output. Let me give you some output from this function. So that's return. And what's going to happen is it's going to say return, and what are we returning? We're going to return x squared plus z squared plus 1. So literally, I just remade this f of xz function right here, But the only thing is I didn't give it a name, right? So I missed one critical step. Like I said function, but I didn't give it a name. So we call this function f of x. But in computer science, we go the keyword function, and this you can kind of think of as let const, right? But this says this is a function. And then we need our name. So we're going to call this, let's just call this fx, right? Like f of x, but fx. And we can declare our function, or we can declare function names as with lowercase letter and another letter. So fx, this works. So we have function fx, and if we ever pass in, let's say 2 and 3 into fx, what happens is this value 2 and this value 3, like, remember I said we're gonna call, I gotta remember I'm not transparent. So, but now I am. All right, but so we're gonna call on right here. So we're gonna call f of x. This is calling the function that I just defined this function right here. Define our function right there, right? And so now I'm calling this function right here. And so when I call this function, this is the call, this is the definition. In the definition, I say x and y, but when I call it, I actually give it some real values for x and y. So 2 is going to be in the place of x, and 3 is going to be in the place of y. But I forgot that's a z, my bad. So x and z. So 2 is going to be in the place of x, and 3 is going to be in the place of z. And so yeah, so that's when we call it the function. And so x and z here these are variable names. These are what you call like generic. I would call this like a generic for the definition. Like this is just a generic value x, and so whatever value we come in for x, we just always gonna square it. Whatever value we get for z, we're always gonna square it and then add 1 to it. So this should give us 14. So that's how this function works. But then I could call f of x on another set of values, let's say 4 and 5, like that. And so now I get a different return. This returned 14. This one returned 4 squared is 16 plus 25 plus 1. So 17 plus 25 is 42, I think, off the top. So yeah, 42. So there you go. So you see that we're doing this same functionality of x squared z squared plus 1. We're doing that same functionality that we just did here from this math function. We brought it down to the computer science and rewrote it. We translated it into the JavaScript right there. A little messy. I'm hip, but it definitely flows. So we call, and we can keep calling the function. This is our call. We pass in data to it, and so this is how we create our own functions right here. But there's also more syntax. So let's see, function, we got this one syntax that goes function, and then we get function name. So let's go fx, and then we do our parameter list. Let's just go x and z. Our parameter, this is what it's called. Parameters is what it's called. These input values, these are called parameters. When you're defining, they're called parameters. When you're calling, they're called arguments. What are the arguments? What are the input values that you're giving to f of x? And then you do your curly bracket, and then you do return. Let's do x squared plus z squared plus 1, right? Well, we're going to rewrite this in another way. So there's this concept called anonymous functions. And so what is an anonymous function? Well, it kind of goes back to the thing of anonymous strings. Like I can just have the string hello, not tied to anything. I can have the value 4, not tied to anything. Like these are anonymous. This is an anonymous string. This is an anonymous number because they don't have any variables. Var name. Let me not use var. I'm gonna say let name. So we got let name equals hello. So now hello isn't anonymous anymore. Before it's still anonymous because there's no identifier that's connected to it. So we can also have anonymous functions, and the way that we create anonymous functions is this way. And so it's this arrow syntax. And so you can see the parameter list right here. The list of parameters, which was x and z. And then this arrow is kind of like, this is kind of like just saying equal. It's just like, I don't know, it's the syntax. So it's like, this the parameter list, and the parameter list is going to go into this function maybe. And so then this function is just the list of commands. And so I just made it on the one line, but you typically would make a new line and then put your commands in between, right? So that's the anonymous function. And so with the anonymous function, you can tie it up to, let's say, const f of x. You can tie it up to a variable. So now f of x equals this anonymous function, and if I ever wanted to call f of x, and I passed in 3, 4, we know that that's going to pass, giving me back 42. So this version of f of x, when f of x is written like this, oh man, I didn't know it was off the screen already, or two for so long. Dang, it's been off the screen for a minute, huh? All right, let me see. Might have to go back and re-explain because they got parameter lists. Oh, no, they just got the parameter list. That's when it went off. Okay. Man, this technical difficulty stuff. Okay, so you got the parameter list, and I just need to make it equal f of x, and then we'll be straight. iPass still connecting. Oh, there we go. Cool, right there. Yeah. All right, yep. So what I did was I said const fx equals that anonymous function that I just drew. And remember that the anonymous function, that's this arrow, that's going to say that this parameter list gets inserted into this list of commands. Okay. And that's pretty much it. So, yep, this f of x is equal to the same, this f of x, just different syntax, right? You got const f of x, then you got function. The reason I show you the syntax is because I use the arrow syntax all the time. And if you're going to follow along on the channel, you most likely going to be using the arrow syntax as well. You might as well just pick it up because although it looks scary, it's really not that hard. And it's just a lot easier to write. And so for real, that is our intro to functions for real. And there's more specific things that you got to get into when you think about functions, like pass by value and reference and all of that stuff. But this is JavaScript, so I'm not really getting into it. That's the best part about explaining JavaScript. You don't got to explain that type of stuff, but you do got to explain like this term where shoot, forgot the term, but it will come back to my head and I'll make a video on it. But you do gotta scope. Yeah, there we go. So you kind of do have to explain scope, which is where you define your variables and where they live inside of your program. Like if you define a variable outside of a function, right? You can have your overall program, and then you just start declaring variables, and then you can start declaring functions as well, and then you start using those variables in the function and whatnot. So we have a discussion on scope. But that's not going to be anytime soon. We're going to get that discussion as we are practicing creating websites rather than trying to do it now, because it just probably wouldn't make much sense. So what we did today was a lot, for real. Honestly, you took up the knowledge from the conditional and all this stuff before, and now we can package all of that different logic into different segments and call them functions. And so you can kind of think, if we ever wanted to create let's say an addition function, which we already got an addition operator, but let's say we created a function that's called add 2. Well, let's add 2 and multiply, like add 2 and multiply 6. Like we create a function that says that add 2 and multiply 6. And so basically it would take in some input, and whatever the input was, it would add 2 to it and multiply it by 6 and give you an output. And we could do that for any value, any number that they give us. The user gives the function, and then the function will evaluate. And so you will see that the important part of the function is that it can be used multiple times. It can be reused. It can be extracted from the program and put into another program and be used as well. So functions help us really a lot, and that is real key. So because functions help us a lot, sometimes these functions, though, some functions run faster than other functions because they're doing more, like they're doing simpler things. Like some functions just simply add 1 and 1 together, but then you have functions that request data from a server across the world. Adding 1 plus 1 is way faster than requesting a server across the world to get some data back, or to give it some data. So in that sense, we have when you're doing like simple tasks like 1+1, like move this data from this registry to another registry, that 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 type of information, that type of instruction is a synchronous instruction. And remember, I told you that the program, the CPU reads line by line by line the instructions that you give it. So it's gonna, and 9 times out of 10, you're writing synchronous instructions. Just synchronous being that the instructions is gonna happen one after the other, after the other, after the other. So meaning that 1+1 is gonna happen, and then after 1+1 finishes, then the next line happens, and then after that line finishes, then the next line happens. So that's what synchronous programming is. But then you got this term, once again, you got this term asynchronous programming, and it's tied to the sense of like the CPU doing a bunch of work and having to wait. So let's say that we were 1+, we did 1+1, and then we did, or no, we were going to ask the server for some data, and it took like 3 seconds for the server to come back for the data. And then our next command, all we wanted to do was just do 1+1, and that next command didn't really depend upon the data being back from the server. So we can actually like run that next command. But in synchronous programming, we have to wait. We have to literally wait until that command comes back, and then we could run a 1+1. Well, asynchronous programming allows us to fire off that, yo, server, go give me that data that's far off somewhere. And as I wait for you, I'm going to go and process this 1+1. I'm going to process what's under 1+1. Then I'm going to come back around once you say the data has come back, I'm going to come back around and then process what you just and handle that data that just came back and process it and whatnot. So that's the sense of asynchronous programming, and then both of those goes off of functions. You got your synchronous functions, your asynchronous functions. You got your synchronous commands, your asynchronous commands, and so we're gonna really talk about that in the next one. Like I said, we talked about it a lot. Actually, I already talked about it a lot in this one, but in the next one we go a little bit more deep and look at some syntax as well. All right, so like always, drop a like, subscribe, comment, and I'll see y'all in the next video. Peace.